Okay, grade 12, so let's work on this question 5. This is an easy question on general solution. They say we need to solve for general solution for theta if sine 2 theta plus the cos of theta is equals to 0. So first thing first, check what type of a general solution is this. But now, to make everything easy, I check, do I have common factor? No, not yet. Why? Because we know that the sine of 2 theta, we can change this and write it as 2 the sine theta, the cos of theta. That's the first thing I'm going to do. So I'm going to rewrite this equation as 2 the sine theta, the cos theta. So now, when you rewrite this equation, you can see that so far I have a common factor of what? I have a common factor of cos theta. Can I take the common factor out? Yes, because can you see if we take out the common factor, we're going to have what we call the zero product property. So, but before that, let's take out the common factor. I have the cos of theta out inside the bracket. Can you see that this cos is out? What are we left with? We only have 2 the sine theta, because if we say the cos theta multiplied by 2 sine theta, we need to get 2 sine theta cos theta. So now remember, we don't have this anymore. We took out the cos theta, so we need something that when we multiply with cos theta, we get cos theta. So the best thing is 1. So we only left with 1. You're going to equate this to 0. So now we're going to apply what we call the zero product property. Remember, if I have A multiplied by B and this is equal to 0, I can take A equated to 0, or I can take B equated to 0. So we're going to consider the cos theta as A. We take the cos theta, we equate it to 0, or we take everything inside the bracket and equate it to what? Equate it to 0. I think everyone is happy with that. So now let's start working with the cos of theta is equal to 0. We need to first work on that. What you can do, you can just check in which quadrant is 0. This is in quadrant 1. So now, if it is in quadrant 1, what do we do? So remember, this is the Cartesian plane, because this is the important part that you need to make sure that you understand. So on the Cartesian plane, this is how it looks like. I have this as 270. Remember, this is just theta, right? In this quadrant, we have 180, because if I have 180, I need to go back to 90. I need to subtract. So 180 minus theta is in quadrant 2. This side is 180 plus theta. This will be 360 minus theta. So now what I'm going to do, I check which quadrant am I working on. It's quadrant 1, it is just theta. So now you need to find your ref. Your ref angle will be equal to the cos inverse of that 0. Maybe we can write that down and say the cos inverse of 0. So you should get your reference angle as what? Your reference angle as 90 degrees. But now, because we are working with, we check 0 is positive. Now we can say the cos is positive. Where is cos positive? In quadrant 1 and 4. So now in quadrant 1, our answer will just be theta. You see, just theta. So you should just have 90. We're going to add, we're going to say theta is equal to 90. So when you're dealing with general solution for cos and sine, you add k times 360 degrees. So this is for quadrant 1. This is for quadrant 1, for quad 1, right? So for quadrant 4, this is where theta is also positive. We're going to have theta is equal to 360 minus reference angle, right? As you can see, 360 minus reference angle will give us 270. So this will be 270 degrees. You add k times 360 degrees. Then that's it for the cos. Then now you need to work with the other side. 2 the sine of theta, take the 1 to the other side. This will be negative 1. Therefore, divide both sides by 2 to have the sine of theta is equal to minus 1 over 2. So now I think everyone can see that our solution here is what? Our solution is negative. you need to check where is sine negative. It's negative in quadrant 3 and 4. So now first thing first, find your reference angle, which is the sine inverse of 1/2. Please do not include negative, because the negative, it tells us which quadrant we should work on. It's quadrant 3. So theta will be in quadrant 3. Can you see it's 180 plus reference angle? So theta will be 180. We need to add the reference angle. What do you get when you say sine inverse of 1/2? You're going to find your sine inverse as what? Your sine inverse as 60. Your reference angle is going to be 60. So this is 60 degrees. So now if this is 60, okay, so if this is 60, we're going to say this is 180. No, I'm sorry, it's 30. This should be 30. Right. So this is 30. The sine inverse of 1/2 is 30. I'm very sorry about that. So now it's going to be 180 plus 30. So it should be 210 degrees. You add what? You add k times 360 degrees. That's for quadrant 3. For quadrant 4, theta will be what? Is 360 minus 30. So it will be 330 degrees. 330 degrees plus k times 360 degrees. That's how you solve a general solution. Of course, there are other methods that we can use to work on this. There are other methods that we can use. But that's it for this problem. So now, when you have this type of question, first thing first, check what type of general solution are you working on. Can you take out the common factor? Is this a quadratic? Is this the quadratic one? Can I factorize? You see, now this was an easy one. So on our next one, we're going to see to work with other types of quadratic. The one where you have to factorize the quadratic formula.